Alright guys, welcome back to another video, and today, as you can see by the title we got going on here, we're talking about working with standard form. Now before we get there, I want to briefly refresh your recollection on these linear equations that we've been spending the past couple of weeks talking about in class. So when we say a linear equation, what we're referring to is an equation that represents a linear graph algebraically. And a few things I want to flag for you there. The word linear, as you see it there, has that word line in it, L-I-N-E. And so when we say a linear graph, we're just talking about a graph that represents a straight line or models a straight line. And when we use this phrase algebraically, remember algebra is dealing with unknowns. We have variables in those equations, namely x and y. Now there are three main formats we present linear equations in, and they are slope-intercept form, point-slope form, and lastly, the star of the show today, standard form. So those are the three different ways we typically represent these linear equations. Slope-intercept form, simply put, y equals mx plus b. Point-slope is a little more complex. Y minus y1 equals m times x minus x1. And standard form is written as ax plus by equals c. Alright, so these are kind of the three different ways we can write these linear equations, and each of them gives us some helpful information about the graph that we're looking at just by kind of inspection. That just means by looking at the equation. Slope-intercept form, as the name suggests, gives us m, which is our slope, and b, which is our y-intercept, also called our initial value. Point-slope form gives us, again, the name kind of tells us, the slope, and x1, y1, which are the y value and the x value of a point on our line. All right, so each of these is kind of helpful in so far as we can kind of see these pieces of information by inspection, and those pieces of information allow us to get a graph up of these equations pretty quickly. But standard form is kind of the odd one out, because when it comes to standard form, we don't really get to see too much about the equation right away. We don't get the y-intercept, we don't get the slope, we don't get a point. And so with standard form, we have to do a bit of work if we're ever going to figure out what the graph of this line looks like. All right. So the focus of today is going to be, what exactly can we do to this standard form equation? How far can we take it to really get us information about whatever graph this equation will represent? So we're going to take it to this worksheet, which you should also have in front of you for those of you following along during tutoring. And the first ask for this worksheet is, the following equations are in standard form. Rewrite each slope-intercept form and then identify the slope and y-intercept for the graph of each equation. So that's two parts, and I'll highlight those. First, we got to rewrite. Where am I at? Oh, I'm down there. Ooh, let me get back over it. So first, we're going to rewrite. And then second, we're going to identify the slope and the y-intercept. And we're rewriting in slope-intercept form. So we're going from ax plus by equals c to y equals mx plus b. Let me write that little reminder up here. So we know what our equation should look like by the time we're done. So we'll take it to x plus 3y to start here. And remembering that whenever we're solving this for slope-intercept form, we're solving for the y, okay? So we're going to draw a little line under the equal sign. And for this first one, it's going to be pretty straightforward. I look to the left of the y, and I see that it's positive, right? So I don't have to worry too much about the sign of the y value. One thing we can also keep in mind, which might be somewhat helpful for us here, is remembering the identity property, right? If we see plus y, that's the same thing as saying plus 1y. But we also have this x on this side, and that's the first thing we're going to target. I want you to remember that whenever we're getting rid of full terms, in this case this x or this 1x, and that's probably the more helpful place to place 1 for identity property. Remember that whenever I want to move an entire term, in this case I want to move all of this 1x, that's going to involve either subtraction or addition depending on what sign the term already has. And because we're looking at a positive 1x here, there's no sign to the left of it to indicate otherwise, we're going to go ahead and we're going to subtract 1x on both sides. On the left side of the equation, the 1x and the negative 1x are going to cancel each other out. And now we're just left with that y. And over on the right side, we have 3 minus 1x. Now we could write that a couple of different ways. We could write 3 minus 1x, just as we see it, recognizing that there's no combining like terms here because we don't have like terms. 3 doesn't have an x on it, negative 1 does, so we can't do 3 minus 1. And so this is a mathematically correct way to write this. However, it's not the most helpful, because ultimately what we want to get our equation to look like, if you'll remember, is y is equal to mx plus b. All right? And in that, hopefully you notice that mx term is first and that constant b is second. So if I want to make it so that that's happening with our equation, what it makes the most sense to do is to use the commutative property to swap around negative 1x and 3. This is going to go to the front, and this is going to go to the back. And we're allowed to do that so long as every term keeps its sign. So the 1x has to remain negative, and the 3 has to remain positive as we make this movement. And so we can rewrite this as negative 1x plus 3. Okay? And so now we have our equation, and it's in the proper slope-intercept form. And so that's part 1 of what they asked us to accomplish. It's in slope-intercept form. The second thing they asked us to do was identify the slope and the y-intercept. And so if you remember from that brief discussion we had previously, the slope is going to be whatever number m is in front of the x value here. We see that is negative 1. And the y-intercept is going to be whatever number is the constant in this equation. In this case, it's at the back. That is 3. Okay? So I don't want you to express it like that. What I want you to do is to write it as a set of equations. M is equal to negative 1. B is equal to 3. All right? And that's going to be our first equation taken care of. We're going to go over here to number 2. And the difference you're seeing between number 2 and number 1, let me go ahead and erase the little model we have there, is that the sign in front of the y this time is negative instead of positive. That's going to add one more step to what we're working with here. But the first step remains the same, right? I see a positive x. We said a positive 1x. And so we're still going to subtract 1x from both sides. Okay? 1x minus y minus 1x. The 1x's are going to cancel out because they're opposites and they both have variables, or the same variables, so they're like terms. And so we have negative y. Over on the right, as we discussed previously, to get this as close to slope-intercept form as possible, right from the jump this time, we're going to write this as negative 1x plus 3. That commutative property. So now we have a similar setup to what we dealt with in number 1, but our job isn't quite done yet because, as we pointed out, y is negative right now. And so it isn't technically considered by itself. We got to figure out a way to get rid of that negative sign. And there's a few different ways you can think about it. Here's the easiest. Just like we used identity property to put a 1 in front of that x initially, we can do the same thing with the y here. Right? Negative y is the same thing as negative 1y, or negative 1 times y. And that helps us because now we see our next step should be to divide everything by negative 1. And interestingly enough, we could solve the problem if we multiplied everything by negative 1 as well, because those have the same effect. But we'll keep it logically consistent. We'll divide everything by negative 1, and that's going to get us y is equal to negative 1x divided by negative 1. All that does is turn that term positive, so now that is 1x. And 3 divided by negative 1, that's going to turn that term negative, so now we're looking at a negative 3. Okay? So now this is the equation fully solved for y. Y is positive, and there's no coefficient. There's no other term there. So we know our job is done. And just like before, we're going to look for our slope and our y-intercept. We see there we're looking at a slope in m, this time of positive 1, and a y-intercept of negative 3. All right? That's 2 out of the 4 equations we're looking to take care of. Next, we're going on to number 2. Or actually, that should be... I mislabeled that, so that should be number 3. I'll fix that when I print these out. So, this will be number 3 for us here. You can imagine that's a 3. This one says 2x plus 3y equals 4. And just like before, our job is going to be let's solve for y. The only new addition here is these coefficients. We're not going to add too many steps to our problem here because not too much is different. But let's think about what we have to do here. So in order to consider y by itself, we have these two things we got to get rid of. There's 2x to start. And then eventually, we're also going to get rid of this positive 3. Okay? If we moved both of those squares away from the left side, then we'd have the y by itself. So those are the two things we got to take care of. Now, if we're looking at the 2x, that's in a whole separate term from the positive 3y. And so subtraction, just like we did previously, is going to get rid of that. 2x and negative 2x cancel each other out. And so we have 3y. And over here on the right, 4 minus 2x, we discussed it a few times now. The most helpful way to write that for our purposes is negative 2x plus 4. So now we've got that positive 3 in front of the y to consider. And the best way to handle that, the best way to divide those two up so that they're no longer conjoined by that multiplication, so that 3 is no longer a coefficient for y, is with division. If we have to split up the term, if we have to divide those two identities or those two items, then we are literally dividing. We're dividing by that 3 because that's what we want to get rid of. Okay? So 3y divided by 3. The 3's cancel out. They get us y or 1y. But in this particular case, it's helpful to write y. And over on the right, everything here is being divided by 3, and none of it simplifies very nicely, so we're just going to write it all out. Negative 2x divided by 3, negative 2 divided by 3, that's just negative 2/3. And the x is going to come down with that. And 4 divided by 3, it's going to get us 4/3. So luckily for this equation, we don't have to graph it, or for this problem, they don't have to graph it, but we are going to go ahead and identify the slope and the y-intercept, same as before. The slope for this one is negative 2/3. And the y-intercept is 4/3. Now for the last one here, I'm going to give you a few minutes to kind of try this one out for yourself. You can pause the video here, and after we get those few minutes, we're going to talk about how this one will look when you solve it. In reality, it's not too different from the ones before. So take a few minutes, go ahead and solve this. And we're going to take a look. So draw the line, same as usual. We look at the 3x, we look at our y term, which now has a negative coefficient, negative 2. Regardless, the first step still seems to be get rid of that positive term out front, and the best way to do that is to subtract it from both sides. 3x minus 3x, those cancel each other out. We're left with negative 2y. And over here on the right, negative 5 minus 3x, we can write that as negative 3x minus 5. Now all we got to do is divide up this term, negative 2y. We're dividing negative 2 because that's what we want gone. Negative 2y divided by negative 2, the negative 2's cancel each other out, and so we're left with y. 1y, but again, in this particular case, it's most helpful to just write it as y. And over on the right, negative 3x minus 5 divided by negative 2. Everything there gets divided by that negative 2. So a negative 3x divided by a negative 2 is a positive 3/2. The x can come down with it. And over on the right, negative 5 over negative 2 is going to get us a positive 5/2. Okay. And let's finish off with identifying that slope and that y-intercept. The slope is the number next to x here. We see that is 3/2. And the y-intercept is this number over here on the right. That is a constant. That is 5/2. 5/2. Okay? And so that is that. So we're going to move on in the worksheet. We're looking at the bottom now. It says, based on your observations from exercises 1 through 4, and without performing calculations or rewriting the equation in a different form, find the following information about the slope and y-intercept of the graphs of the given equations. So they give us these equations in their standard form, ax plus by equals c, and they ask us about whether the slope and the y-intercept are positive, negative, or 0. And the practice here really is just kind of envisioning this process of solving without actually having to do it, okay? So if we look at number 5, let's think about what we have seen as patterns between these first 4. What we've seen is that that x term is getting moved over, and by the time everything is said and done, whatever number is in that x term, the coefficient, ends up being the slope, all right? What we've also seen is that number, that's c, that's over here, the constant, by the time we make it all the way to the end, in some way, shape, or form, it ends up being our y-intercept, all right? And so if we're looking at our x term here, we see that it's a positive 5x, which means when we move it over to the other side of the equation, it's going to be a negative 5x, okay? So as of right now, our slope number, we're going to call it our slope number, is a negative number, negative 5x, once we move it over to the right side of the equal sign. 4 remains positive because we didn't do anything to it. Once we get y by itself by dividing by this negative number, the 5 that became negative once we moved it is getting divided by this negative 3 we're going to see here, right? And if we look at a negative divided by a negative, that should give us a positive. So the slope for this particular equation, regardless of what it is, we know for sure should be a positive number. Now, as for the y-intercept, the only thing we would really be doing to change the sign for the 4 here is dividing both sides by this negative 3. And when we do that, this positive 4 getting divided by this negative 3 would end up giving us a negative number. So for this equation, the slope would be positive, but the y-intercept would be negative. I'm going to give you a minute or two here to try that same logic with number 6, and we'll come back in to discuss it. All right. So if we're looking at what we've got here, we've got a positive 4x, a positive 7y, and a negative 2 for our c term. We'd be subtracting 4x from both sides, and so that 4x would become negative. And then we'd be dividing it by positive 7. Now, a negative 4 divided by a positive 7 would give us a slope that is a negative number. And if we look at the y-intercept, it started off as a negative 2, and we divide by a positive 7, so that's also going to be a negative number. Okay? So this process of solving in standard form, once you do it enough times, you see there start to be patterns, and you can kind of pick up on bits and pieces of what this line would look like before you even touch it algebraically or before you even try to graph it. So now we're going to flip over our pages here. We're going to look at the back side. Draw number 7. I'm going to give you some more time here to solve this equation. They say they want us to solve the equation ax plus by equals c, the standard form for y. All right? So take a few minutes here, pause the video, and go ahead and give that a shot. Okay. So if we're solving this for y, we're getting y by itself. And we've done this enough times already to see that the pattern is going to be the same. It's just a matter of how much we can simplify this equation. So as it was the case the first couple of times we did this, we're going to start by subtracting that x term. In this case, it's just ax. Ax and negative ax cancel each other out. We're left with by. And that's going to be equal to, most helpfully written, negative ax plus c. Just because we no longer have numbers doesn't mean our properties of equality change or our properties of real numbers change at all. Because each of these variables represents some number. We just don't know what it is. We can still use algebra on it. And then we're going to divide up this y term by dividing everything by b. All right? And so what that's going to leave us with is y is equal to negative a over b times x plus c over b. And that's that. And so this is kind of helpful to have as you practice with standard form, understanding that getting from standard form to slope-intercept form really is just writing the equation that you see in standard form. You're taking the a, the b, and the c, and you're kind of putting it in this format. That can save you a lot of time and effort. Really and truly, it's not that much faster than just solving the equation for y, but this is a nice little cheat sheet all the same. we're going to go down to number 8, where they ask us to identify the slope and the y-intercept of the graph of ax plus by equals c in terms of a, b, and c. So we're going to rewrite that equation we just got in slope-intercept form to help us do that. And that was y is equal to negative a over b times x plus c over b. Okay? Now you remember by comparing this to our slope-intercept form, and I'll move the m a little bit closer. That our slope is whatever number is attached to the x. And you also remember that our y-intercept is whatever number is the constant, usually to the right. So if they want us to write this in terms of a, b, and c, and we're talking about the slope and the y-intercept specifically, we could say slope is equal to negative a over b. And we could say that the y-intercept is going to be equal to c over b. And that's that. And now we're going to finish off with number 9 here, where we can kind of pick through all the work we've done through this worksheet to help us answer these questions. Because the idea here is they want us to think about standard form, they want us to think about all the algebraic movements we've been doing, and they want us to give information about this equation given a few bits of context they provide to us. Okay? So it says, complete the following sentence about ax plus by equals c. And the first sentence reads, if a is greater than 0 and b is greater than 0, then the graph of the equation has either a positive, a negative, or a 0 slope. So let's look for that. Let's look for a place in this worksheet where we've had an a value greater than 0 and a b value greater than 0. And hopefully, you can come over here to number 3, right? A here is 2, and b here is 3. Both of those are greater than 0. So when we have a situation like that, a is greater than 0 and b is greater than 0, what do we notice about the slope? The slope here is negative 2/3. That's a negative number. And so what we would pick is the slope of the graph has a or the graph of the equation has a negative slope. Going on to the next one, if a is greater than 0 and b is less than 0, then the graph of the equation has a positive negative 0 slope. So now we're going to look through our worksheet for where a is greater than 0 and b is less than 0. And you can look over here at number 4, right? A is 3, b is negative 2. And so when we had that set up, what we saw was that our slope ended up being positive. So, for that one, we would pick a positive slope. The next sentence reads, if the slope of the graph is greater than 1, then the absolute value of a is greater than, less than, or equal to the absolute value of b. All right? So let's search around for a situation where the slope of the graph is greater than 1. And we saw that to be true again here in number 4. Right? In number 4, our slope is 3/2, which is larger than 2/2. And so that's greater than 1, right? Because 2/2, if I were to write that out real quick, would equal 1. 3/2 would be equal to 1.5. Okay? If the denominator is bigger, then you're looking at a number bigger than 1. Or rather, if the numerator is bigger, my apologies, you're looking at a number bigger than 1. So, bit of context, bit of helpful advice. 4 is another good example for what we're looking at here. So if our slope is greater than 1, what they're saying is the absolute value of A is going to be something related to the absolute value of B. So if we look at our A value here, that's 3. And so I'll say the absolute value of 3. And if we look at our B value, that is -2. So the absolute value of -2. Now, hopefully, you remember our conversation about absolute value from prior videos and prior sessions. When we say absolute value, all we mean is that number's distance away from 0 on the number line. So if I were to take the absolute value of 3, that's 3. And if I were to take the absolute value of -2, that is 2. Because -2 is 2 spaces away from 0 on the number line. And when we do that, we get 3 has some relation to 2. Obviously, you would say 3 is greater than 2. And because 3 was our A value here and 2 was our, or -2 was our B value, what that shows us is if the slope of the graph is greater than 1, then the absolute value of A must be greater than the absolute value of B. All right. Next scenario says if B is greater than 0 and C is greater than 0, then the y-intercept of the graph is either positive, negative, or 0. So let's find a situation for that. B is greater than 0 and C is greater than 0. And so a good example of that is right over here at 3. And maybe really and truly we could use 1 or 3. Let's use 1. Why not? So for number 1, our B value was 1 because of that identity property, right? And our C value is 3. Go ahead and write that. And so when we had that situation, right, our B value is greater than 1 and our B value is greater than 0 and our C value is greater than 0, what we notice about the y-intercept of the graph is that it is a positive number, right? So we can go ahead and circle positive. For the next one, it says if B is greater than 0 and C is less than 0, what's going to be true about the y-intercept of the graph? So we're looking for a B value greater than 0 and a C value less than 0. Now that wasn't true of any of the situations here, right? But we did deal with that down here in number 6. And when we saw that, what we noticed was that the y-intercept for this situation we deduced was going to be negative. Now, for the fun of it, let's just go ahead and prove that. Let's do it algebraically. So we have 4x plus 7y equals -2. I know they told us not to do this when we were answering number 6, but just for the sake of thoroughness, let's go ahead and do it here now that we've kind of done what number 6 asked us to do. So if we were to solve this equation for y, we start by subtracting 4x from both sides, that ax term. That's going to leave us with 7y is equal to, at this point we understand the x term should be written first to be as helpful as possible. And so the last thing we're going to do is divide everything by 7. And we end up with y is equal to -4/7 x minus 2/7. They're asking us about the y-intercept here. And so we just kind of proved algebraically that that is going to be a -2/7. That's going to be a negative number value. Last one we're looking at here, last bit of number 9, last sentence, it says, if the y-intercept of the graph is greater than 1, then the absolute value of b has some relation, either greater than, less than, or equal to the absolute value of c. All right? So let's try to find a situation for that. The y-intercept of the value of the graph is greater than 1. And we found that to be true in a couple of different places. Let's take a look at number, is that true here? No, y-intercept is negative. So let's go to number 3. I was trying to avoid it, but it's helpful here. All right. So the y-intercept we found to be 4/3. Based on the conversation we had about fractions earlier, you understand that 4/3, the numerator is bigger, so that is bigger than 1, right? And so they're saying, if the y-intercept is greater than 1, what's the relationship between the absolute value of b and c? So for this one, our b value equals 3, and our c value equals 4. All right? And so again, we're doing the same thing here. Absolute value of b compared to the absolute value of c, 3 and 4. Now, because these are both positive, there's not much thinking to do. 3 is 3 spaces away from 0 on the number line, and 4 is 4 spaces. And so we would say that the absolute value of b must be less than the absolute value of c. And so that's what we're going to put right here. All right? And so that is that. So a couple of things to remember about standard form. It's not the most helpful form to be given or the most helpful form to start off with, but based on some simple algebra, we can take it and we can turn it into its much more helpful slope-intercept form, which we can use to graph. And another thing that we'll probably talk about is this idea that even if we're given standard form, and maybe for whatever reason slope-intercept form isn't helpful to us, we can still find information from standard form that we could use to create graphs, just with some simple algebraic manipulations. So we'll talk about that a little bit in the future, but for right now, take care.